Okay, hello ladies and gentlemen, welcome to my YouTube channel. In this video, I'm going to share my experience in network automation using Cisco NSO. Some of you may already know about Cisco NSO. It is one of the network automation tools created by Cisco that can help us doing network automation. It is quite powerful, and the benefit is Cisco NSO is not only supported for Cisco devices, but it can support also for multi-vendor. For example, like ALU or Alcatel-Lucent, and then Juniper, and also the Dell Forsten. It can be supported by Cisco NSO using its network element driver. Okay, as you can see in my screen here, I have built a topology in GNS3. So basically this is my personal project that I created using GNS3 as my favorite simulator. Here I have some routers that are connected to my virtual machine, where the Cisco NSO and others automation tools are installed. So I'm using Ubuntu server 16.4 virtual machine that is connected to the 172.16.68.0/24 network. Yeah, this is the network management that will be connected to all routers. Yeah, all routers management interface using this segment. Okay, some of routers are using Cisco IOS-XRv. For example, like router 1 until router 6, we can consider it as a service provider routers, where L3 VPN services and segment routing MPLS LDP are running. And then for the green routers, for example, like CE A1, CE B1, and so on, they are using Cisco IOS-XRv. Yeah. Okay. This is some sort of introduction about the topology or scenario that we are going to build. And for automation using Cisco NSO, we are just involve the R1, R2, R7, R4, and R6. Okay, for this video, let's jump to the Cisco NSO first. Okay, I think I need to check my Cisco NSO. Okay, to check whether your Cisco NSO is already started or not, you can type this command. Okay, I need to enter to the Cisco NSO directory. You can just type ncs -status grep state. Okay, connection issues means there is no Cisco NSO services is running. In that case, we need to start it first with the ncs command. Just type ncs under ncs run directory, and then type enter. Press enter, and let's wait for a couple of minutes. Okay, for you guys that quite new in Cisco NSO and you didn't know how to pre-set up or do the initial config of Cisco NSO, you can check my blog. I have created notes in how to configure Cisco NSO for the beginning, and also yeah, for doing initial setup in Cisco NSO. You can check my blog later and see in the comment in this video or in the description. Okay, seems like the NCS is started already. Let's check. Okay, you can see the status is changed now. It means that NSO is already started. Then we can access to the web UI. Once you successfully start the NCS services, you can go to the web browser and then type the HTTP and then your virtual machine. I type my virtual machine IP here, 1668.10 port 8080. Alright, yeah, this is the initial dashboard of Cisco NSO, Network Services Orchestrator. By default, NSO using admin password, but in my case I already changed it. I already create my local user for NSO using NetLab. Yeah, and you can see here the dashboard. We have our 4 menus: commit manager, configuration editor, and device manager, and service manager as well. First of all, we need to check the device manager. This is all the device inventory. You can consider it as device inventory, where you can see all the registered device. Okay, in this scenario, I already registered the R1 until R7, which is the all service provider routers that we are going to automate using NSO, already registered here. But for the customer edge, I'm not going to use Cisco NSO. Instead, I'm going to use Ansible for automation tool in next section. Okay, first thing, we need to check the connectivity on each router, because we are only using R1, R2, R7, R4, R6. We are not going to use R3 and R5. So let's check the status of R1, R2, R6, and R7. Okay, let's ping. Okay, here NSO will show you the green status, which is good. If let's say there is a problem in the connectivity, it will show you the red color. We can also connect the devices from NSO by typing or click this menu. You select all the device that you want to connect, and then here in the top right corner you can see this logo, and then just click connect, and let's wait until we get all greens. Okay, seems like all the connection is good, and then yeah, then we check the configuration synchronization, yeah, because basically we want to make sure that the configuration in the Cisco NSO and in the local routers are synchronized. So in that case, we need to click check sync. So if let's say your device has a different configuration with the NSO configuration here, so basically all the configuration will be stored in the Cisco NSO. But in case you make some changes but it's not synchronized to Cisco NSO, then this status will not be in the green status. It will show you the red color. That means you have a different configuration between Cisco NSO and the your local router devices. In that case, you can push a configuration from NSO to the device using sync to. Just click sync to. It means you are pushing the configuration from NSO server to your local routers, or you can collect or pull the configuration from local routers to the NSO to make it all synchronized between NSO and the device. But in this case, because we already have all configuration are in sync, so we can continue it. Okay, so it's all about the device status, and now we jump to the service manager. So basically, if you didn't make some configuration, or you don't have any template for the service, you will see this blank screen. But here, because I already create my own services, I have two services here. I have a SPF underlay, which is this service or this template will be using for configuring routing protocol, and then the MPLS LDP activation, and also segment routing under these services. But for the second services, for VPN services, this one to enable L3 VPN services between the customer. Yeah. Okay, to save my time, I already pre-configured some of the routers, for example like R1, R2, R3, R4 and R5, but R6, R7 are still not configured here. So in this demo I will show you. But before we jump to the configuration, I just want to give you a short brief about the script. Okay, you can see here you can create a service. All those services are created based on this data modeling. We are using Yang data modeling, so I created a Yang file here. I put all the parameters, the variables that I want to use in the Cisco NSO. I have defined it here, and then we are using the XML template to push the configuration. So basically these two configuration, Yang and also XML, are really dependent each other. So we call all the basically we call all the variables in the Yang data modeling in the our XML template, and then we push this configuration via Cisco NSO. Yeah, this is the SPF underlay, Yang data modeling, and this is the OSPF underlay template for the XML configuration, and this is for VPN services. And yeah, for the details of this script, I've put in my GitHub. You can check it later. But now let's continue with the configuration in the NSO. Yeah, first I want to create okay, R6, because here R6 is considered a PE router that is connected to CE82 and CEB2. So I want to configure R6 for MPLS LDP. Yeah, let's add R6 underlay transport. Okay. I think you can hide all these parameters. Yeah. Okay, so this is all the variables that I have created using Yang data modeling. We have router ID, we have OSPF ID, device. You can choose which device you want to configure, RID, and so on. So and all those variables will be pushed to the device using XML template configuration. Okay, for the default, let's start. OSPF ID is 1, and then we are going to configure on R6, and router ID is 60. Let's put 60.6. Okay, and then we enable MPLS LDP first. Later on we will enable segment routing, but first I want to activate using MPLS LDP first. R6 RID is 0. Okay, loopback interface you can choose loopback 0, and then gigabit interface. I think it is using gig 4 and also gig 6. No, gig 5. It's okay, gig 5 we are not using it, but it's okay, we can put it here. But at least gig 4 is the gigabit at thread 0004 is connected to router 4. So this interface is gigabit 004. Okay, so we need to enable it for the MPLS LDP. Okay, about mapping server, SR prefix seed, RSVPT, later on we are going to discuss in next chapter, but because in this case we just want to enable the MPLS LDP, so we don't use segment routing variables at this time. Okay, let's check in the commit manager. Yeah, once you create the template, you input all the parameters for the respective routers, so you can check here. So yeah, basically it will check what configuration that are going to push to the device. This is in JSON format, I think, but we can check also in the native config. So once you create or input all the parameters, it's not directly will be pushed to the device, but it will ask you to make a confirmation whether this configuration is correct or not, so you can check before you push all the configuration. This is a good point because it will reduce the human error, or you can check whether your configuration is correct or not in this part, in this section. Once you make sure that all the configuration is correct, then you can just press commit here. Okay, let's check. Okay, before I commit, let's check first. Let's verify on R6 that we have an existing configuration for MPLS LDP and router SPF. Yeah. Okay, so in this configuration, NSO will push the router OSPF and also MPLS LDP. Yeah, but let's check if we have a router OSPF. Nothing, and then LDP. Oh, also nothing. So before we push this configuration, there is still no pre-configuration on the R6, but let's check after we push. Now let's click commit. Yes, commit, and let's wait until it shows done status, then you can verify it in the router. Okay, it's done. Now let's check. Previously we have no OSPF and MPLS LDP configuration. Let's now check. Okay, you see router OSPF configuration already pushed here from NSO, and then MPLS LDP also here. Let's check the OSPF status. So OSPF neighbor. Okay, it's full. It has peering to router 4 in interface gig 004. And then let's check the MPLS LDP neighbor. Yeah, MPLS LDP neighbor already established as well in the gig 004, because in router 4 previously we already pre-configured using NSO as well. So now it's automatically established the MPLS LDP. Okay, yeah, I think, yeah, let's check MPLS forwarding table. Okay, you can see here we got all the MPLS label in router 6. Let's count it how many label that we have in router 6. Okay, here we have around 15 rows, 15 lines, or we can consider 15 labels using MPLS LDP. But later on I want to show you when we are activating segment routing we can compare how many MPLS or how many labels that we have in router 6 after we change to segment routing. So we have a comparison between MPLS LDP and segment routing. Okay, now all settle. Again, let's check the configuration. Okay, click check sync. Okay, up to this point we still didn't use the R7 because R7 I'm planning to use it for the SR mapping server. What is SR mapping server? We'll check later on. Just follow this video. You will see what is the functionality of SR mapping server. Okay, we have already configured the R6 with the MPLS LDP, and now we are going to change all the routers for router 1, router 2, 4 and 6 using segment routing. Yeah, let's say we can do it from here. Okay, let's say router 1. Okay, the segment routing is still disabled, so here I'm going to enable it. Let's say prefix it, we can use 1, and then it's not a mapping server. Okay, we can disable also the MPLS LDP. The block LDP is also to segment routing. Yep, let's check. Now I'm going to convert the MPLS LDP into the segment routing. Yeah, we are going to activate the segment routing here one by one on each router. Start from the router 1 first. Okay, it is done. Let's continue from the next router, router 2. Also want to disable it. Okay, now change to 2, prefix it. Okay, plug LDP through. Okay, let's continue on router 4. Yeah, router 4, we are going to enable it for segment routing and disable for MPLS LDP. Router 4 with prefix it is 4. What is prefix it and then segment routing global block? I think you need to read the segment routing introduction. It has a lot of reference in internet. You can check what is segment routing and what is SR prefix it, what is segment routing, and what is the sRGB, and so on. There are a lot of reference outside there, but I'm not going to discuss it here. I assume that you already have familiar with the MPLS LDP and also segment routing. So, okay, this is R4. Basically, yeah, we are going to apply the segment routing and remove MPLS LDP. Up to this point, we still didn't enable the L3 VPN services. So we just want to make sure that underlay or the transport are working as our expectation. Okay, service. Now for the R6 now we enable it as well. Let's check. Okay, this is the last router, and then after that we are going to configure R7 for mapping server. But before we apply on the R7, just want to make sure that segment routing is already configured on R6 and R1, R2 and R4 as well. Okay, I believe the MPLS LDP configuration is already removed. Okay, no MPLS LDP, and here this is the previous capture. While we are running MPLS LDP, we have around 15 labels or 15 prefix here. But then if let's say you are using segment routing, now you are already running a segment routing. Here segment routing is already enabled. Let's see how many labels in the R6. See, the label is already reduced up to 8 labels. We can consider as up to 8. This is one of the benefit of the segment routing. Yeah, so the reduction of the labels in the MPLS LDP, it's quite significant. So because in the segment routing you just label the significant prefix or the interested prefix that you want to install in the MPLS forwarding table. Let's see forwarding. Okay, now it's changed. SR prefix. Yeah, it show you the segment routing. Sounds good. Okay, so here you can see the benefit of segment routing. Yeah, and next, okay, while you are doing migration from MPLS LDP to segment routing, of course, if let's say you build the segment routing from the greenfield, then it is easier than you migrating from existing MPLS LDP to segment routing. Yeah, that's why we need to have we call it here as a mapping server. Yeah, to do migration, to help us while we are doing a migration from MPLS LDP to segment routing, because the function of mapping server itself is like to transforming your MPLS LDP label to the segment routing label. So let's say in this topology we have already segment routing running on R1, R2, R4 and then R6. But let's say R6 we are not going to activate segment routing. These R6 are still running in MPLS LDP. Without the mapping server, we are not able. This R4 is running both segment routing and MPLS LDP, yeah? But R6 is just purely running MPLS LDP. Then in that case, we won't be able to transfer, or we won't be able to send the traffic from R1 to R6 and vice versa. Because why? Because R1 and R2 are already pre-configured with segment routing, and they don't have visibility on the MPLS LDP label in between R6 and R4. That's why we need to have a mapping server. In this case, I want to use R7 as a mapping server, so that it can perform, or it can have the transformation from the MPLS LDP label to the segment routing label, and vice versa. Yeah, actually you can install the segment routing mapping server in any routers in the SR domain. Yeah, okay, so R1, R2 until R4 up to this point are running in SR domain, but for R6 up to this interface of R4 running using MPLS LDP. Let's try to enable it first. Okay, R4, I'm going to run MPLS LDP and segment routing at the same time. So it's possible to run a segment routing and MPLS LDP at the same time during the migration. Yeah? And you can choose, or you can prefer which protocol you want to use, either the segment routing or the MPLS LDP in the configuration. But in this case, R4, because it is connected to the R2 as well using segment routing, so in my template I prefer using segment routing if, let's say, there is a connectivity to SR devices. But if, let's say, there is no capability on the peer device running segment routing, then it will be using the MPLS LDP. Okay, don't block the LDP. Yes, commit manager. Let's check. In this case, I want to re-enable the MPLS LDP on R4. Commit. And let's wait. Okay, in the meanwhile, let's check on R7 what is the configuration inside there. So IPv4 interface brief. No, yeah, actually I have already pre-configured the interface, but again, the routing protocol, for example OSPF and segment routing, I didn't configure it yet. MPLS LDP also nothing here, so I'm planning to use this R7 as mapping server. Yeah, okay. Let's go back. Okay, it's done, I think, in the R4. Let's check on R4 if the configuration is already pushed to the device properly. Okay, so MPLS LDP enable. Oh no, yeah, because the MPLS LDP on R6 still not enable. So, but let's check on the configuration. Okay, it's already configured, but at the same time we also enable a segment routing here. Yeah, MPLS and segment routing is enabled on R4, and now let's configure on R6 become MPLS LDP only. Here, okay, I just remove it. Remove and then toggle LDP and then make it true. The rest okay, fine, I think. Yes, we remove the segment routing and also re-enable the MPLS LDP. Let's commit. Okay, let's wait for a couple of minutes and see configuration. Okay, it's done. Let's check on R6. Okay, previously it's running segment routing, but now it changed to MPLS LDP. Okay, so router SPF, no segment routing enabled here, but we enable the MPLS LDP. Okay, let's check the MPLS LDP enable. Okay, sounds good. But yeah, as I mentioned before, as the rule of thumbs of the segment routing and LDP communication, yeah, you need to check for the details about the SR to LDP domain interchange correlation, yeah. So in that case, we need to have a mapping server. I want to enable the routing server on R7. Okay, let's create a new services for R7 underlay transport. Okay, for R7 here we choose R7. Okay, for R7 we are not going to enable LDP. We don't need to enable LDP here, but we will enable segment routing, and we choose this router as mapping server. Okay, then select true, and then what interface? Okay, 0, and then interface this interface gig 2 as well as gig 4, because our server is connected to router 2 and router 4. Yeah, we need to enable these two interface. And then mapping server. Okay, so this mapping server prefix, what is the prefix? This is the prefix of the LDP router, which is the 60.60.60.6. yeah, we want to mapping the prefix in the LDP domain that we need to transform or transpose to the segment routing. Okay, the prefix mask is 32, and then prefix interval we can start from 1000, let's say 1001, and then prefix range, this is the number of prefix in the LDP domain that you want to map to the segment routing domain, and the interval is the what we call it the range that we want to add in the sRGB of segment routing. So basically the default sRGB will be add with this interval. For example, like the default is 16,000 in the segment routing domain. In let's say we want to transpose or we want to transform the LDP domain or LDP prefix to the SR domain, we need to add this SID interval. Let's say we can start with 1000, and then because we have only one router that we want to map, then just put 1 here. Native config. Yeah, basically this is a configuration in R7 to enable segment routing as well as the mapping server. Yeah, let's check push commit. Okay, let's wait. Yeah, it's done. Let's check on R7. Previously we don't have MPLS LDP, yes, but in the router SPF now should have a configuration with the segment routing enabled, and also the segment routing prefix. Yep, it's there. And to verify the mapping server, you can type segment routing mapping server prefix it map pv4 detail. So basically we are going to map this prefix on the router R6 with the SID index is 1000. Yeah. Okay, so this is how to enable the automation in the segment routing and MPLS network using Cisco NSO. Yeah, and then yeah, I think we have done for the transport configuration, but now we need also to enable on the R6 for L3 VPN services. Let's the configuration there. And then now, okay, yeah, I already configured for R1 because R1 considered as a PE routers that is facing to the customer edge in the left side, and I want to enable on the R6. Yeah, R6. Okay, let's enable the L3 VPN service and we test it later. Okay, let's start with the VRF. Yeah. Sorry, R6 customer VRF. Well, we need to configure the VRF creation. This is R6 customer. We can define our customer name, let's say customer A, and then I also create a customer B. Yeah. And then the loopback interface is, yeah, loopback 0, I think. No, loopback 0, I'm not going to advertise it. I'm using loopback 1. Let's say loopback 1. We use loopback 1, let's say 6 255 255 255. Oops, sorry. 255, and then customer, let's say we can put as customer A. Okay, and then for the gigabit interface, yeah, I want to assign this gigabit interface in customer A, which is this is gig 006 facing to the CE82 as a customer A. And then for gig 0007 connecting to CEB2 as customer B. Yeah. 6 and 7. Okay, let's choose confirm this one. We can configure 19.2.1 255.255.255.252 gig VRF customer A interface enable true. Yeah, we need to enable it. Okay, and we can add one more interface for customer B. Customer B is using 100.100.2.1 255.255.255.252, then customer B, and then enable it. Yes, true. Let's say I get the configuration 9992, yes, 100.100.2. Okay, okay, it's supposed to be there. Then let's check the configuration. Okay, if you have customer A, oh, hold on a second, I think I forgot some configuration. Okay, customer A, yeah, we also need to define the route target. Let's say we put here customer A is 5 sorry, no, exported 91.1, 99.1. okay, and then for customer B is 101 and also 101. Yeah, this root target must be matched also in the router 1, yeah, otherwise your prefix will not be advertised and cannot receive each other. Okay, native config. Okay, let's push. Well, okay, let's check the configuration after this. Okay, I think R6 configuration, let's check. Show run. Okay, and we need to check also in the R1 whether the root target is matching. Show run. Yeah, we are using 991 and 101. Okay, sounds good. And then we also need to create another services for customer that are using BGP routing or using a static routing. For R1, we already create the services. This service is used by customer B, and then for this service, static route is used by customer A. We also need to replicate this service as well in router 6. Let's configure it. R6 R6 customer BGP route. Confirm. Okay, now we want to create a BGP routing for R6. yeah, we have a AS number. This is the AS number for MPBGP. It's true MBGP router ID 60.60.6. we enable all these things. Yes, okay, and the peer ID is the loopback of router 1. Peer ID is okay. Let's check. Loopback interface is 0. Yes, and then we create a VRF name. Yeah, let's say we create for customer B. Confirm. Root distinguisher ID is 101. Customer BGP, yes. Customer BGP pair. Okay, this is the supposedly the this IP, the customer B2, 100.102.2, let's say, yeah. 100.100.2.2. Okay, customer AS number is 65002. Okay, so customer B using AS number 65002 and our provider using AS number 65001. yeah, okay. No static and also no network advertise. This variable actually, if let's say you have a directly connected interface, then you want to advertise it, you can put here just for testing. But in this case, I'm not going to use it. I just want to have a pair with my customer. I want to create a BGP peering template in the PE for peering with customer B. Yeah, I think that's all. Let's check the configuration. Router BGP, yes. Okay, this is the pairing with R1 for MPBGP, and then this is for pairing with our customer CE router. 100.102.2. Okay, let's push. Yep, done already. And for the last one, okay, let's create the R6 services for customer that is using static route. Yeah, R6 customer static route. Okay, so basically this service will be used for this customer CEA2. It from CEA2 will be configured with the default route towards the R6, and same for the CEA1 as well. It has a static route towards to R1, but we are going to configure it using Ansible for each router in the customer edge. Yeah, we are not going to use NSO as I mentioned before. Okay, let's check. Sorry, customer 6. Okay, we want to create a static route. Static node is R6, and then what is static network address? Yeah, we want to use 99.2. This is the loopback 0 of CEA2. Yeah, we are going to use it for our customer traffic, let's say. And let my sister to confirm. Let's check customer VRF name, customer A, and then next hop is the supposedly should be the IP address of this interface. Yeah, the fast Ethernet 00 of CEA2. We can put it here. Let's say 199.99.2.2. Native config and see, and then 299.99.2.2. Okay, let's push the config. Okay, it's done. Let's check on R6. Yeah, router BGP. Okay, it's configured, and then router static, it's configured as well. Okay, I think we already configured all the services in the provider. So yeah, I think this network from R1 to R6 is already configured and ready to forward the traffic. But we need to configure the customer edge first. Let's close it. Yeah, this case I just want to make sure that we have all configuration all configuration in sync mode. So let's check the synchronization status for all devices. Remember that R1, R2 and R4, they are running segment routing, and also R7, but R7 is mapping server, and R4, especially R4, it is running segment routing and also MPLS LDP. And then for the last R6, it is only running MPLS LDP. And see whether we can have reachability from the customer, from customer A and also customer B. Okay, I think it's all enough for this video session. I just want to show you how to use NSO to automate your network, and how do you build the template and services. And yeah, I hope this video is informative for you. in the next video, we are going to configure the customer edge router using Ansible. Okay, stay tuned in this channel, and thank you for watching.